Alright guys, so you just got done watching that cool video with the popcorn. So this is kind of just go hand in hand with what happens. So if you have these two things, just kind of what they said. They said 3 cones give you the volume of a cylinder. And we have 2 examples here that will show you in this case. Here you have a cylinder and a cone with the same height. Remember, they have to have the same height for that to work. So basically they had the same height, and you can see that the volume of this cylinder is 120 inches cubed and the volume of this cone is 40 inches cubed. So you can see by base what they said that if I took this and divided it by 3, or what they said multiplied that by 1/3, 120 times 1/3, you can see that you end up getting 40 in this case. Same thing here for in this one. If I were to multiply this by 1/3 or divide by 3, 90 times 1/3 or 90 divided by 3 would also give me 30. So using these examples, you can see that a cone compared to the volume of a cylinder with the same radius and the same height is going to be that the volume of a cone is 3 times smaller than the volume of a cylinder. Or you could say the cylinder is 3 times bigger than the volume of a cone. So that's how they kind of came up with that formula there, what they came up with. That's where the 1/3 comes in, and that's where we have to solve our volume of our cone. So in this case, just to kind of fill some things in and use that information that they told us, they said that the volume of a cone will always be blank the volume of a cylinder with the same height. Will be 1/3 the volume of the cylinder of the same height. So basically what they say is we're going to take the same formula for a cylinder, and we're just going to simply multiply it by 1/3 at the end, and bam, there will be our volume for our cone. So the formula for the volume of a cone is, and you can take it right off here off your yellow sheet. Right here is where it says for our cone, and you notice that it's got the same things for us. So the volume of a cone here is just simply going to be 1/3 times pi times our radius squared times our height. And it will be able to give us the volume of any cone that you have, as long as you know the radius and as long as you can know the height. So let's look at a few examples here. So here's your first example here that you've got. You've got a cone that's laid on its side. It shows that you've got the radius of 5. You've got a height of 12. So this is my height. And we want to be able to find the volume. Okay, so we're going to write down the formula here. 1/3 times pi r squared times the height. And I'm going to plug in my values of what I know. So I already know that I have the 1/3. I know for pi I'm going to use 3.14. For the radius I'm going to use 5, so that's 5 squared, or 5 times 5. And then for the height it becomes 12. And you can put that all right in your calculator with using some parentheses and stuff. By putting it right in your calculator, let me show you what we're going to do. So to put in the 1/3, I'm going to put parentheses 1 divided by 3. Then I'm going to multiply it by pi, 3.14. I'm going to put in my radius, 5, and I'm going to square it. Then I'm going to put in my height, which was 12. So that's what I put into my calculator there, or I can break it up into pieces if I needed to do that as well. So I've got 1/3 in parentheses times 3.14 times 5 squared times 12. I hit enter, and it tells me the volume of this cone is 314 inches cubed. So that's one way you can write that. Now that is an approximation using pi. Now if I wanted to write it in pi notation, what I would need to do then is just do 1/3, 1 divided by 3, times 5 squared, times 12, leave the pi out, and I get 100, and I could write it out as 100 times pi. That would be the more approximate. That would be the exact value right there. 100 times pi inches cubed. So that would be two ways you can write that one. Okay? Let's look at our second example here. It's the same thing, but this time it's a little bit different. I got a cone this time that's straight up. This is my height, is 10. My radius, well, I don't have a radius. This is my diameter. You can see that it goes all the way across my circle. My diameter goes all the way across. If you look at example 1, my radius was just halfway across. So I need to find what my radius would be. So my radius is going to be half of the diameter. So I need to divide that by 2, and it gives me 11. Now I can use my formula there, 1/3 times pi times the radius squared times the height. Plug in the values that I know. I know 1/3. Pi, I'm going to use 3.14. The radius is going to be 11 because I took half of the diameter, 22, gives me 11. And I'm going to square it. And my height is going to be 10. Now I can put that onto my calculator, or I can do bits and pieces at one time. It does not matter. But if I want, I'm going to put it all into my calculator here so I can do that. So I'm going to do it again by putting parentheses around the 1/3, 1 divided by 3. Need to put parentheses around it so that my calculator can use the order of operations correctly. Times 3.14 times my radius squared, which was 11, times 10, my height. And it gives me this big long decimal here, 1,266.46666, and I'm just going to round that up to the nearest hundredth. So I'm going to take this third 6, and it's going to round that 6 up to a 7. So my answer there will be 1,266.47 centimeters cubed. Thank you very much.
Hey there, Anthony here from Mashup Math, and thank you for joining me on this lesson where we are going to visually explore a question based on the 8th grade math standards. Let's go ahead and check it out. Hey everyone, welcome back. You know, it's always cool when you get to apply your geometry skills to the real world. Let's go ahead and do that right now. In this scenario, we have a parking cone with a radius of 6.2 inches and a height of 18.3 inches. And our challenge is to find the volume to the nearest cubic inch of this cone. Now, whenever we're trying to solve a geometry problem, we want to create a diagram. Those two things pretty much go hand in hand. So for our diagram, we have a cone, and we know that the radius of that cone on the circle at the base is 6.2, and we also know that the height is 18.3, and this information is going to prove useful to us. And we should know that when we want to find something like volume of a three-dimensional figure, we always have formulas that will help us. So for this problem, we go into our geometry tool belt and we pull out the formula for finding the volume of a cone, which is V equals pi r squared times 1/3 of the height. And all we have to do now is plug in the information and then we can solve. Now we know that r, the radius, is 6.2. And we know that h, the height, is 18.3. So we can substitute those two values into the formula. Now remember that there's a lot of multiplication going on here in this formula. We have pi times 6.2 squared times 18.3 over 3. So you may want to use parentheses when you substitute these values in. Now from here, we just have to simplify and evaluate. Now 6.2 squared is equal to 38.44. 18.3 divided by 3 is just 6.1, and our final product is going to be 736 with a long never-ending decimal. It's an irrational number. And remember that we wanted to express the volume to the nearest tenth of a cubic inch, so we have to round our answer here. Now we can do that by looking at the value to the right of the 10th decimal place, so to the right of the 6th. In the 1000th decimal place, that value happens to be a 5, and we know when that value is 5 or greater, we have to round up, and our final answer is 736.7 cubic inches, the volume of the cone.
Ha, cool.